a lot of funny things would be fun. All right, guys. So we did basics of exponentials, and now we're gonna. I'm in a weird mood, and now we're gonna do basics of log functions. So log functions. There we go. Okay, log functions and exponentials are inverses of each other, just like adding and subtracting are inverses, and multiplying and dividing are inverses. And so since they're inverses, like you can write a subtraction, like 2 minus 3, you can write that as an addition because they're inverses. You could write 2 plus negative 3. And so just like log and exponentials, they're inverses, so you can write them as each other, okay? And so notice to write them like each other, notice where the stuff goes. So what equals is the exponent. See? The base right here on the log is the base on the underneath the exponent. And then the big number for the log is what equals over here. Right? So maybe just write that pattern down. So there are two different ways to say basically the same thing. Okay, and so right now, all we're going to do is go back and forth between log and exponent. So the base, 5, is the base of the exponent, and then what equals is the new is the exponent for the exponential equation, and then what equals is the big. So 5 squared equals x. FYI, 5 squared is 25. But this is how you rewrite it. Let's do it this way. So this would be b is the base to the 3 equals 64. That's how you rewrite it. FYI, 4 times 4 times 4 is 64. So is correct. So you know, right? 3 is the base. Y would be our exponent, and then 7 is some decimal, so I'm not going to do that one. But that's how you rewrite it. All right, let's do the next. So now we're going to go opposite. Okay, and so this one can be a little confusing. So we're going to have log, some base here, some number here, equal sign, and then something. All right, so the base will be 12. The exponent will be what it equals. So it'll be like 12 squared. And then what it equals is now the big number right here. And just so you know, 12 squared, 144. So we could actually solve that, but I just want you to rewrite it. Right here, log, okay, the base would be b, and then equals, the 3 goes over here, the exponent goes over there, and then the 8 goes here. Just so you know, so that's how you rewrite it. Just so you know, 2 times 2 times 2 is 3. Okay, here we have e. E is natural log. So instead of writing log, I'm going to write natural log, ln. It's backwards because of Latin. A lot of times English is backwards in Spanish, then Latin, then German. All right, so natural log e equals, okay, the y, and 9. And it's some decimal, so I'm not going to write it, but that's how you rewrite it. Okay, natural log automatically has a base b. We don't really need to write the e. We need to write natural log 9 equals y. Log automatically has a base 10. If we ever see log 10 with something here and something here, they will just write log whatever it is here, whatever, because that 10's invisible. And the reason log has a base 10 is because we have 10 numbers in our system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You kind of counted wrong with my fingers, but we're just going to skip over that and pretend nobody knows. Okay. So log has a natural base of 10, and so if there's nothing written right here in the base, it's understood to be 10. And so on your calculator, we'll learn later in another video, the calculator only deals with log base 10. So if there's a different number here, we have to do what's called a change of base. That's in a different video. And then natural log has a, it's always e, which is the number 2.7 la-di-da. It's a whole bunch of numbers. All right, these are just some properties. I don't necessarily expect you to memorize them. Look at them, and then we'll do some problems, and hopefully doing the problems, you'll kind of learn them. So if we rewrite this guy, it would be that b to the 1, and anything to the 1 is b. Okay? Or you could think of it as these cancel those b's right there, and so you just get 1. So you're taking notes. Taking notes. You can. Right here, we can rewrite this guy as this b to the 0, 1, because anything to the 0 power is 1. If you need to go back and review exponential rules in the schedule, I put a link to an old video about exponential rules. All right, also, b to this x, so b to the x, so those two things I underline equals, and then I'm just rewriting it using exponential form, b to the x. That's the circle thing. And we'll learn later that when the bases are the exact same, the exponents equal each other. Right? You can also think of it as this. These b's cancel each other, and so you get the x. Okay. Same logic. So this is an 8-week course, so I'm not going to really go into the super math of it, but same logic of all that cancels. B log base b, so you just have the x equals the x. All right, so we're going to rewrite and evaluate, and if it makes you feel better, just write like equals x, and so we can figure out what it equals. Equals x, and we can figure out like what it simplifies to. So first, let's rewrite it. So 2, you can't see that. Well, I can't. You can. 2 to that x equals 16. So we need to figure out 2 to what power is 16. So 2 times 2 is 4, not 16. 2 times 2 times 2 is 8, not 16. 2 times 2 times 2 times 2 is 16. So 2 to the 4th is 16. It means that x is 4. Right here, those 7's cancel, so we get x equals 3. Really that simple. All right, let's do here. Let's just make it equal x. Equal x. Okay, this means 7. Some number equals 1 over 49. Okay, well, hopefully in your mind you're like, oh, well, I know 7 squared equals 49. This is 1 over 49. All right, well, let's think real quick back to like the rules of exponents. All right, 49 is the same as 7 squared. Okay, but we need both the 7's to be on the same playing field. We either need both on the bottom or both on the top. And so it's really easy to make them both on the top. So if we did 7 squared equals, so 1 over 7 squared, that's the same as saying 7 to the negative 2. Because a negative exponent means move it, move it, move it, move it. So this guy's saying, hey, move me back down to the bottom. All right, so since these two bases are the same, oh, this isn't x. I keep putting a 2 because I know the answer. So since these 7's right here are the exact same, and they just go away. For an 8-week course, I'm not going to get into that of it. They go away, and so x equals negative 2. Okay, over here, this is the same as saying log 2 to the 1/5. Okay, just like square root is the same as 1/2 power. Third root is the same as 1/3 power. Fourth root is the same as 1/4 power. So fifth root is the same as 1/5 power. Equals x. Those cancel. So I get 1/5 equals x. Right? Let's go equals x. Right? This says 5 to some power is 1. And the rules of exponent says some number, the 0 power is always 1. So 0. 5 to the 0 power is 1. So x is 0. This over here says 4 to the x equals the big 4. And so the rules of exponent says any number to the first power is that same number. So 4 to the first power is 1. Here, same thing. So these guys cancel. So I get 9 equals x. This says 3 to some power is 27. Well, 3 squared is 9. It's not 27. 3 times 3 times 3 is 27. So 3, my answer. Okay, and I'm going to stop the video because I want to talk about graphing, but I don't want to like rush it. So in the next video, I'll talk about graphing. Not hard. Don't worry.